Okay, so I just made one video with the double angle formulas and worked through the derivation of one of them as well as how to actually use it to solve a problem. Now we're going to work on what's called the power reducing formulas. And again, much like I said in the last one, these formulas, the power reducing ones, can be rather cumbersome. And all things being completely honest and equal here, there's maybe not that much usefulness for them right now. But the goal of this class is to get you ready for Calc 1 and Calc 2 in particular. And these formulas are important. They're much like the double angle formulas where some problems can't be solved in certain situations, and we need tricks to simplify the problems so we can solve them, and one of the tricks are these power reducing formulas. So again, I'm aware that these formulas can be rather cumbersome, but we do need them. Ultimately, we need a familiarity with them, which is why I'm kind of going over this and letting us work with them and practice with them. Last time I derived this double angle formula for sine, and I told you guys, and in your lab you will derive the double angle formulas for cosine. And I had said in your book there's 3 versions of them. Last time, I think, in one of the problems we used cosine 2 theta equals cosine squared minus sine squared. There's actually 2 other versions of it. And in order to get these formulas, just so you can see how they're derived, we're going to use one of the other double angle formulas for cosine. And it's this: cosine of 2 theta equals 1 minus 2 sine squared of theta. Now, this is called the power reducing formula. Basically, power reducing formulas have to do with trig functions that are raised to powers. So, I care about this sine squared, so isolate it. And again, this is just an algebra trick. You want to get sine squared by itself, subtract the 1. So you get cosine 2 theta minus 1 equals negative 2 sine squared theta. And then divide both sides by negative 2. Dividing by the negative will flip the signs of both of these, so I'll just reverse them. And I get 1 minus cosine 2 theta all over the 2 equals sine squared theta. And there we go. That's called the power reducing formula. I'm not going to derive it here. It's in your book, and you can derive it yourself using the other cosine double angle formula, the one with a cosine squared here. It's slightly different, but I'll leave that up to you. But that one, you actually get cosine squared of theta equals 1 plus cosine 2 theta all over 2. And again, I would stress, these are in your book. It's an online class, so you're not necessarily going to have to memorize. You should just know where they are and be able to use them quickly. But ultimately, you will use them in upper level math classes, and you should be able to derive them on your own even if you don't remember them. We use the sum angle formulas to get the double angle formulas, and then we use the double angle formulas to derive the power reducing formulas. So all these things work together as long as you can do your algebra. But we have our power reducing formulas, and again, the idea from a mathematical perspective why we care about it is, if I have something, sine squared, I had the one for cosine squared, but we're going to focus on this. If I have a trig function raised to a power, maybe solving something out with that is too confusing because it's raised to a power. This formula allows me to write it in terms of a linear trig function, cosine to 2 theta, which in some instances is easier than the power trig function. So it's just a trick we can use, and we do use it, like I said, in upper level math classes. But to see it in action, let's see. I'm going to need room for this, so maybe we'll start writing it over here, and we can erase all of that. And we will just write over here, say sine squared of theta equals 1 minus cosine of 2 theta all over 2. Now, reduce sine to the 4th of theta. And again, the idea here is to essentially take that 4th degree sine there and reduce it down to just linear trig functions, be they sines, be they cosines, be they whatever. Get rid of the powers, reduce them until they're all linear. Well, how do we do that? Let's see. Sine to the fourth is clearly sine squared of theta squared, because that's the fourth power. But sine squared of theta is just equal to 1 minus cosine 2 theta all over 2. So now I replace sine squared theta with 1 minus cosine 2 theta over 2, but then square that, because that whole thing was squared. Again, this is just a substitution. Don't get lost and think I'm doing complex math. I'm substituting that with that, because that's what the formula says to do. Now I get to do math. And again, don't get lost in it. I'm just squaring. On the bottom, 2 squared is 4. That's easy. On the top is where it gets messy, a little bit, but this is just a perfect square. 1 minus cosine 2 theta times 1 minus cosine 2 theta. So square it out. And right up top here, and yes, I'm deliberately using different colors so you can hopefully see each thing clearly. If I FOIL, 1 times 1 is 1. 1 times negative cosine 2 theta is negative cosine 2 theta. And then I get negative cosine 2 theta times 1, which is negative cosine 2 theta. So I get minus 2 cosine 2 theta. Now, negative cosine 2 theta times negative cosine 2 theta is positive cosine squared 2 theta. And there we go. If I kind of simplify that out, and again, this whiteboard is rather small, so I'm not maybe going to be able to do all the algebra out before I have to erase and keep going. But if I simplify this, I can break it up as 3 fractions. And I get 1 over 4, which is 1/4, minus 2 over 4, which is 1/2 times cosine 2 theta. So we'll just say cosine 2 theta over 2, plus, remember the 4 is over that, cosine squared 2 theta all over 4. The problem is, well, that's a number, so I'm fine. That is a double angle, but it's linear, so I don't really care. I was just trying to reduce the powers. That is still a power, cosine squared. And I wanted to get rid of all the powers. So now I have to get rid of that. So, use the power reducing formula for cosine squared. Again, you guys have it written down in your notes, but in case we've forgotten, cosine squared of theta equals the same as the one for sine squared, but it's a plus. 1 plus cosine 2 theta all over 2. Which means when I rewrite this, I get 1/4 minus cosine 2 theta over 2 plus, and now make sure you keep your algebra straight, this 4 just carries along. It's not part of the cosine squared. Now, use the power reducing formula on cosine squared of 2 theta. And one thing to keep in mind, I am out of different colors, I think, but we'll use the purple. This formula works for theta. Here I have 2 theta, which means I have to alter the formula slightly. I'm sorry, here's my 2 theta up here, they're the same one, but there we go. But in the formula, if you look, whatever is getting squared in here, in this case it's theta, I get 1 plus cosine of 2 theta, twice that. Which means, if I'm squaring 2 theta, then in the formula, I'll get 1 plus cosine of twice that, which is 4 theta, all over 2. And again, I know that looks messy. I'm deliberately writing it somewhat messily to make sure we're clear. This right here, cosine squared of 2 theta, became that, using my formula. Cosine squared of 2 theta became 1 plus cosine 4 theta over 2. This 4 just carries along. Now, I can rewrite this and simplify. Well, let's see. We'll go down here. 1/4 minus cosine of 2 theta all over 2 plus, And here, you know your rules of fractions. This denominator here gets sent to the bottom and multiplied. So it becomes 1 over 2 times 4, 8, plus cosine of 4 theta over 4 times 2, 8. And now, assuming we wanted to kind of expand from here, I can combine these. 1/4 plus 1/8. 1/4 is 2/8, so that's 2/8 plus 1/8, which is 3/8, minus cosine of 2 theta over 2, plus cosine of 4 theta over 8. And there we go. I have reduced all my powers. And keep in mind, we actually started right there with sine to the 4th of theta. So essentially, sine to the 4th of theta equals all of this. 3/8 minus cosine 2 theta over 2 plus cosine 4 theta over 8. And I know that looking at that, you tend to think, oh, there's no way this is easier to solve than that. But again, in upper level math, with some of the problems we solve, it actually turns out that this is an easier form to deal with than that. So we do need to know how to do it. You will have homework problems on this from your book. If you want to actually practice, just pick a problem. I have taught Calculus 2 before and used these, and in that class I tend to give students things like sine to the 4th of x plus cosine squared of x, or something like that. So take something like that. I'm aware we already solved this part right here in the video, but just take something like that and try to work through the algebra on your own using the power reducing formulas. You'll have to reduce this twice like we just did. This one you can just reduce once using the formula and then combine like terms and go from there. Again, yes, it's cumbersome. Since you have 2 of them here, it's going to be even more so. But the algebraic skill is what we're looking for because we need that when we get to higher level math classes. So just use it as practice. There's one more set of formulas in this section that I want to go over. But again, I don't want to make this video too long and boring maybe for those of you who have seen too much algebra at this point. So I'll break it up and I'll do one more video for the last set of formulas.